Hope you had a fun time there. Woohoo! My bear paw back scratcher. I never looked at it as a bear paw. I just called it a back scratcher. But yes, very much looks like a bear paw. And if I do it right, you guys can read through this. Here's the amortization formula, right? You can read through that. Anyway, I'm back. We just did using the formula to calculate a sinking fund. Remember, the sinking fund is to create a future value with payments now. All right, we don't know what the payments are, but what payments do we need to have a particular future value? Well, what if we need to know how many payments do we need at a compounding rate to pay off a present value now? All right, so actually my future value ends up as 0. I pay it off. What we will do is we will use the amortization. This is basically the present value formula for an annuity. And again, we just reconstruct it. We find the derivation. So the amortization payment, say that 10 times real fast, equals the present value, what the loan is now, times I, again, the numerator denominator are flipped, over 1 minus 1 plus I to the negative n. All right? 1 minus 1 plus I to the negative n. All right? We have a negative exponent here. So we should be used to doing these from our present value formulas from section 2 of chapter 12. So let's do a little practice here. Let's look at what it is. All right? So on page 391, if we look down through that, example 10. What amortization payment is required each month at 18% interest? That's robbery, by the way. To pay off $5,000 in 3 years. My goodness, that sounds like a credit card payment. All right. It is compounded each month. All right. And payment each month. And we need to pay off $5,000. So the present value is $5,000 in 3 years. So I is going to be 18% divided by 12. That's 1.5%, 0.015. And N is going to be 3 years compounded monthly. So that should be 36. So N is going to be 36. Yep, so 1.5 for the interest rate per period. And 36 for N, 3 times 12. All right, so you see that there. So the amortization payment should be the present value times, there's our formula. So I is 0.015, 1 minus 1 plus I, raised to the negative 36 power. And then, of course, our present value is $5,000. So they did the math of the denominator, 1 minus all this, and they got 0.4149103. When they divide that into 0.015, they got 0.0361524. 0.0361524. Multiplying that by 5,000, that's $180.76. So your payments at 18% interest to pay off $5,000. Now, this is where you really got to pay attention. Please listen to this. $180.76 times 36 equals $6,507.36. So for that $5,000 at 18%, ouch, you've paid an extra $1,500. All right? You paid an extra $1,500. Now, what would be cool is, what would you have in 3 years at like 7% interest if you put away $200 a month? If you did that, I bet you'd have more than $5,000, and you would have paid less than $6,500 to get that $5,000. So somebody took a $5,000 loan out, and in the end, they paid $6,500. All right, that is what compounding interest is on the negative side of things, when you have to make those payments out at high interest. All right, so this was an 18% interest loan. Not good. Okay, so I just wanted to point that out. Now, practice. I want you to practice, because you can use this formula to figure out your own amortization payments. All right? You can use it to figure out your school loans, a car loan, your mortgage. All right? If you know the terms, you can figure out your payments. And you can also figure out if you make extra payments. Again, I have an amortization table I'm going to post for you guys. I'm going to show you how to use it. And if you make extra payments, it helps you figure out how much you save in the long run. So, with that said, let's do exercise 10 here. Practice exercise 10 under the example 10 on page 391. Apex Manufacturing recently purchased a new computer system for $150,000. All right, that's actually a cheap system. What amortization payment is required each month at 12% interest, ouch, to pay off this obligation in 8 years? All right, so if they want an 8-year payment, an 8-year loan, payments monthly, compounded monthly, how much are they going to have to pay each month? All right, for $150,000 now. How much are they going to pay in 8 years total for $150,000 now? All right, go ahead, use the amortization formula, and when I come back, I'll have the answer.